Okay, lab final 2024 serial number. You can see, for example, this serial number 245940, and look at the OSPF area 45 and network 192.168.26.64, 192.68.25, 224. Okay, close this, then open again. Okay, the serial number will change, 244140, and the area now is 88. It's different. Different networks like 192.168.26, 192, and 192.168.25, 0. Okay, so every time you will open this file, will change some values. Okay, so be careful with this. Obviously, there is a limit. Okay, I will use this example. Okay, you will complete basic device configurations, including OSPF version 2 EIGRP, redistribution, access control lists, NAT, CDP, LLDP, NTP, TFTP servers, and verify end-to-end connectivity. Part A, configuration. Complete initial configuration. Configure IP addresses on all the devices in OSPF area 0 and OSPF area 88. Okay, this is area 0, area 88. Okay. Okay, IP addresses. The following are already configured. All IP addresses in EIGRP Autonomous System 1. Okay. EIGRP Autonomous System 1 already configured with IP addresses on devices. All devices inside the Internet Cloud. All devices inside Internet Cloud. Default routes on R1net and HQR1. Okay, the default route on R1net router and the default route on HQR1 router already configured. Okay, so configure IP addresses. Okay, I will start with R1net. Click here on this router, command line interface, enter, enable, show running config to verify the configuration, enter, space, 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 space. Okay, default routes to internet, 2 default routes to reach internet, so that's why you have 2 default routes. The metric on this is different. Gigabit 0 to 0 configured is this connection to internet, gigabit 0 to 0, with no more configurations. Okay, use the last usable IP address on fast Ethernet 00. Okay, you have this network address. This is a network address. This is not a host address. So the range for host addresses are from 26.193 to 26.254. Okay, this is the range for host addresses. 192 is the network, and 193 is the first IP address. 254 is the last IP address, and 255 is the broadcast address on this subnet. So use the last usable IP address on fast Ethernet 00. Configure terminal interface fast Ethernet 00 IP address 192.168.26, 192, sorry, 192.168.26, 254. Okay, the last address 254, prefix 26. 26 in decimal is 192. Okay, enter. No shutdown. Okay, fast Ethernet 01, last usable IP. This is the network address 192.168.25.0. This is the network address. The first IP is 1. The last IP is 30. The broadcast address is 31. So the range is from 1 to 30. So use the last, should be 30 on fast Ethernet 01. Fast Ethernet 01, IP address 25, 30, and 27 prefix is 224. Okay, 25, 30, prefix 27. 25, 30, prefix 27 is 224. Okay, not shut down. Okay, but also on PC2, configure the first usable IP. And you know the first usable IP is 25.1. 25.1. 192.168, 25.1. Subnet mask 224. This is prefix 27. The default gateway, you know, is the IP address on fast Ethernet 01. So it's 2530. And DNS server not specified. Okay. DNS server not specified. Okay. PC1, the first usable IP. You know, here the first IP address is 26.193, prefix 26. 26.193. 26.193. Prefix 26 is 192. Okay, and the default gateway, you know, is the last 26.254. The IP address on fast Ethernet 00. Remember, on fast Ethernet 00, this IP address 26.254 is this default gateway for PC1. Okay. And for server, second usable IP address. 26, 194, 193 is the first, 194 the second, 26, 192, default gateway 26, 254. Okay, ready. Now configure R1NAT. Configure this interface serial 000. Interface serial 000. And the network is 10.10.0.68. The first IP will be 69 and the second 70. So I will use the first here on R1NAT serial 000 10.10.0.69. IP address 10.10.0.69 and the prefix is 30, 255, 255, 255, 252. Okay, no shutdown. Very good. Don't forget the loopback addresses 11111222. Okay, interface loopback 0, IP address 1111, prefix 24. 24 is 255 to 255 255 0. Okay, it's not necessary non shutdown because the interface change state to up. Loopback 1, IP address 1222 with this prefix 24. Perfect. Okay, very nice. Exit. And now configure serial 000 on HQR1. Review the device command line interface. Enter enable show running config space fast Ethernet configure 0001. This is the connection to internet. This interface connected to the cloud to internet. Is this space? Okay, two default routes because you have two paths to reach internet with these interfaces. Okay, so configure serial 000. Configure terminal interface serial 000. Use the second IP address 10.10.0.70. 255, 255, 255, 252. This is the prefix 30. Okay. Now shut down. Enter. Very good. Okay. Configure multi-area OSPF version 2. Process ID 1 for OSPF. Activate individual networks using network statements and inverse mask, including loopbacks. Okay. Okay, go first to R1NAT. Global configuration mode. Router OSPF. Process ID number 1. Enter. Okay, and advertise the networks using inverse mask or wildcard mask. Do show IP route connected. This command is used to view the directly connected networks. Okay, enter. Now you have two loopback interfaces and one serial interface, 2 fast Ethernet interfaces, and 1 gigabit. Okay, but gigabit 0 to 0 is not part of OSPF. Gigabit 0 to 0 will use a default route to reach internet. Okay, this default route to reach internet. Okay, so do not advertise gigabit 0 to 0. Okay, start with this network 1110, wildcard of 24 or inverse mask is this 000255 area. Okay, loopback interfaces on area 0. Okay, this is another. Okay, same wildcard mask area 0. This serial 000, serial 000 on area 0. Okay, very good. 10, 0, 68. Prefix 30. The wildcard for 30 is 3. Is this the network wildcard area 0? Okay. Now the fast Ethernet interfaces 192.168.25.0. Wildcard for 27 is 31. Okay, wildcard for 27 is 31. With area here on fast Ethernet interfaces, the area is 88. Area 88. This another for fast Ethernet 00, 26.192. Wildcard for 26 is 63. Okay, 63. Area 88. Okay, very good. Enter. Okay, 5 network statements. Okay, do not advertise this. Okay, and now summarize OSPF area 88 routes on R1net with the most specific subnet mask. Okay, first summarize these two networks. This and this another. Okay. Summarize 192, 168, 26, 192, and 192, 168, 25.0. Okay, summarize OSPF area 88 routes. Okay, on OSPF area 88, there are two subnets or two networks. Summarize. Okay, first convert to binary. Okay, I will convert the last two octets to binary because the first two octets will be the same. 192, 168. 26 in binary is 0, 0, 0, 1, 1, 1, 0. Okay, and 192 is 1, 1, 0, 0, 0, 0, 0. Okay, this is 26. 16 plus 8 is 24 plus 2, 26. This is 192. 128 plus 64, 192. And 6 zeros, okay. And 25. The first two octets in decimal will be the same, and the last two octets in binary. 16 plus 8 is 24, plus 1, 25, okay, and 0, 8 zeros. Okay, and summarize this. Is look at this 182, 168, 0, 0, 0, 1, 1, 0. They are the same. 182, 168, 0, 0, 0, 1, 1, 0. They are the same. This bit is different. This is 1 and this is 0. These bits are different. So consider this. 182, 168, 0, 0, 0, 1, 1, 0. Okay. How many bits do you have here? 8 plus 8, 16, 17, 18, 19, 20, 21, 22. So the prefix for the summarization is 22. Okay? But fill the remaining spaces with zeros. 0, 0, dot 0, 0, 0, 0, 0, 0, 0, 0. Okay? And 182, 168, and convert this to decimal. 182, 168. This is 24. 16 plus 8, 24. 0, prefix 22. Okay, but this prefix is 255, 255, 252, 0. Okay, 22 is 252, 0. Okay. Okay, summarize OSPF area 88 routes. Okay, ready. Okay, the most specific subnet mask ready. And obviously on R1net you need to notify this summarization to another neighbor, and should be a OSPF neighbor, and the only one OSPF neighbor is this another router, HQR1 router. So advertise this summarization to this another router. So advertise on serial 000. Okay, so advertise this. Remember, you are on router configuration mode, router OSPF1, router configuration mode, area 88 range, question mark, the IP address. Okay, use this. Question mark, the mask, you know, is this space, question mark, enter. Okay, this is the summarization. Okay, advertise the default routes into OSPF areas. Okay, you know you have default routes, so advertise using default information originate, enter. sorry, default. Okay, ready. Configure LAN interfaces on R1net specific. Okay, fast Ethernet 00 and fast Ethernet 01 passive. Passive interface fast Ethernet 00, fast Ethernet 01. Also, you can add gigabit 020 as passive because it's not part of OSPF process. Configure loopback interfaces as point-to-point networks. Loopback 0 and loopback 1. Okay, exit, interface loopback 0, IP, OSPF, network type, point to point. I'm sorry, okay, IP, OSPF, question mark. Okay, don't forget the process ID. Okay, 1, question mark, the area. No, is IP OSPF network, question mark, point to point. Okay, point to point, enter. Okay, interface loopback 0, IP OSPF network, point to point. Loopback 1, IP OSPF network, point to point. Ready. Okay, don't forget to configure HQR1 for OSPF area 0. Okay, this is for EIGRP, only for OSPF. Okay, that's it. Global configuration mode. Remember the process ID is 1. Router OSPF 1. Show the directly connected networks to show IP route connected. Okay, this is serial 000 is this interface connected to OSPF area 0. Very good. Advertise this. And fast Ethernet 00 for EIGRP. Okay, fast Ethernet 01 for EIGRP. And gigabit will use a static route to reach internet. So only advertise the fields for OSPF network 10.10.068. Wildcard is 3, area 0. Enter. Okay, don't forget this is the summarization is only for R1net. Advertise the default routes. Okay, look at this is the adjacency with another router on OSPF. Okay, network advertised on area 0 and default information originate default. Okay, very nice. This is ready. LAN interfaces specific. No loopback interfaces on this another router. Okay, you can set fast Ethernet 00, fast Ethernet 01, and gigabit 020 as specific interfaces because they are not part of the OSPF process. Okay, passive interface fast Ethernet 00, 01, gigabit 020. Okay, don't worry about this. Exit. Ready. Now configure EIGRP. Okay, disable automatic summarization on all the routers participating in EIGRP. Advertise individual networks using network statements with wildcard masks, including loopback networks. Okay, Boston has loopback networks. advertise the default routes. Okay, summarize loopback 0 and 1 on Boston. Loopback 0 and 1 on Boston. Okay, don't worry. EIGRP Autonomous System 1, you need to configure HQR1 and Boston routers. HQR1 and Boston. Okay, first go with HQR1. The autonomous system is 1. Okay, autonomous system is 1. Router EIGRP autonomous system 1. Okay, these are the directly connected networks. This is for OSPF, the serial 000, and advertise this on EIGRP. Fast Ethernet 00 on EIGRP and Fast Ethernet 01 on EIGRP. Do not advertise this last network because it's the connection to internet that will use static routes. It's not part of EIGRP, so only advertise these two. Network 10.10.0.88 wildcard for 30 is 3, and that is enough. Okay, this very good. Enter. This another network 203.0 113.0 wildcard for 24 is this 000.255. Okay, verify. Very nice. Enter. Okay, don't forget to disable automatic summarization. Now auto summary. Okay, ready, advertise, ready, advertise the default routes, redistribute static, and summarize on Boston. This is Boston configurations. Also, you can configure passive interfaces like serial 000 and the gigabit 020 because they are not participating in EIGRP. You can set these passive interfaces if you want. Passive interfaces serial 000 and gigabit 020 because they are not part of EIGRP. Okay, and for me this is enough. Exit and configure Boston. Enter enable configure terminal router EIGRP1. Okay, before to do this, exit show running config space. Boston is completely configured with loopback addresses, fast Ethernet interfaces. Okay, very good. So configure EIGRP, configure terminal EIGRP autonomous system router EIGRP autonomous system 1 to show IP routes connected. Okay, and don't forget disable automatic summarization. Now auto summary. Okay, and advertise all. Okay, because all interfaces are in EIGRP autonomous system 1. Advertise all. Network 10.10.0.88. Okay. Okay, the adjacency with HQR1 network loopback interface, wildcard. Okay, review. Okay, this another. And finally this network 172.16.0.5.0 wildcard for 27.31. Okay, wildcard for 30 is 3, wildcard for 24 is 255, wildcard for 27 is 31. Okay, review the network, very good. Okay, advertise default routes, no default routes on Boston, so you don't need to advertise default routes. Okay, passive interfaces, no specification for passive interfaces, but you can specify Faceternet 01 as passive interface because you don't have an EIGRP neighbor here. Okay, passive interface Faceternet 01. Okay, this is enough for me. Exit. Okay, advertise default routes. Okay, no default routes on Boston. Okay, and now summarize loopback 0 and loopback 1 on Boston using the most specific subnet mask. Summarize these two. Summarize 145.444 and 145.544. Okay, convert this to binary. Only the first octet will be decimal and the another octets in binary. Okay, this is 128, 64, 32, 16, 8, 4, 2, 1. Okay, okay, this is 4. Okay, 145, this octet in decimal, 5 in binary. This is 5. 4 plus 1 is 5. Okay, and 4, 4. 4, 4. Okay, summarize this. Okay, very good. 145, 0, 0, 0, 0, 0, 1, 0. Okay, they are the same. 145, 0, 0, 0, 0, 0, 1, 0. Okay, these bits are different. Okay, so only consider 145, 0, 0, 0, 0, 0, 1, 0. Okay, only this. They are the same. Okay, so how many bits do you have here? 8 bits plus 9, 10, 11, 12, 13, 14, 15. 15 bits, so the prefix is 15. Okay, but fill the remaining spaces with zeros. Okay, 0. Okay, fill the remaining spaces with 0. and the prefix is 15. Okay, convert this to decimal of 45. This is 400, and 15 in decimal is 255, 254.00. Okay, 255, 254. Okay, if you will configure the summarization on Boston, advertise this to HQR1 router. Okay, on EIGRP on Boston, you can advertise this EIGRP configuration to HQ router. Okay, so Boston should advertise this summarization to HQR1. Okay, you know HQR1 and Boston are part of EIGRP autonomous system number 1. So use Facet Ethernet 00 on Boston to advertise the summarization to HQR1. Okay, so interface Facet Ethernet 00, IP address. Okay, IP question mark is summary address. Okay, IP summary address EIGRP autonomous system number 1, and advertise this summarization. The mask is this. Enter. Very nice. Okay, the adjacency is reset. Okay, exit. Okay, ready. Configure redistribution. Okay, and now a little review on R1net and show running config space. Okay, all the configurations. Okay, show IP route to verify. Okay, directly connected networks, the static route to internet, and this is the OSPF, the summary. You know, area 88 is a summarization of 2 subnets, and this is okay. OSPF doesn't know the existence of EIGRP because you don't have these networks or routes. No EIGRP routes or networks. Review HQR1 and show IP route, OSPF, and the loopback interfaces on R1net, directly connected networks, EIGRP networks, the loopback and 145 networks and 172 networks. 145, so summarization, and 172. Okay, for EIGRP. Remember, D is EIGRP. This OSPF inter area, the summarization of these 2 networks, Directly connected network is this. Directly connected network to internet and route to internet. Okay, anyway, R1 needs the redistribution to know the EIGRP routes or EIGRP networks, okay? So configure this, configure redistribution, redistribute EIGRP routes into OSPF, okay? The boundary router is this HQR1 because this boundary router is placed between OSPF and EIGRP. So configure HQR1 for redistribution. Okay, redistribute EIGRP into OSPF. Configure terminal. First, access to OSPF, router OSPF. Remember the process for OSPF is number 1. Redistribute EIGRP. Autonomous system of EIGRP is 1. Redistribute all subnets. Okay, enter. Very nice. That's it. Now redistribute OSPF process 1 into EIGRP. Router EIGRP1, access first router EIGRP, and redistribute OSPF process 1 with metrics, question mark, sorry, redistribute OSPF1 question mark. Okay, question mark. Okay, again, question mark, redistribute, okay, this was the error, redistribute, it's only redistribute, OSPF1, metric, question mark, bandwidth, 10,000. Question mark, delay, 100. Question mark, reliability, 255. Reliability, 255. Question mark, load only 1. Load 1. Maximum transmit unit 1500. Question mark, maximum transmit unit MTU 1500. Okay, enter. Very good. Okay, remember the command, enter to router EIGRP 1 and redistribute OSPF with this matrix. Okay, redistribute the static routes into EIGRP. Okay, you are in EIGRP, redistribute the static, redistribute static. Okay, exit. Now verify and go to R1net, look at the routing table, repeat, show IP route, space. Now the routing table has more entries like this OSPF external 2. Okay, OSPF external type 2. Okay, these are 1, 2, 3, and 4 networks from EIGRP. Okay, 1, 2, 3, and 4 networks. Okay, configure access control list. Configure each of the following access lists on the appropriate router, and then apply it to the appropriate interface. In the appropriate direction, create named standard access control list called block-bty. Only PC2 should be able to access the BTY lines of router R1net. Use the host keyword. All other traffic must be explicitly denied. Okay, this is the access for BTY lines on R1net. Okay, go to R1net, review the configuration, show running config, space. These are the BTY lines. Okay, configure a password to verify later. Configure terminal 9 BTY 0 to 15 password. For example, Cisco is an insecure password only for test and login. Exit. Okay, and because BTY lines only was configured with login, but no password. Okay, no password. Now you have a password. And create a name and standard access list. Okay, IP access list standard block BTY case sensitive. Be careful, block BTY. Enter. Only PC2 should be able to access BTY lines on R1net. Okay, PC2 25.1. Okay, 25.1. Only one IP address. Permit host this IP address. Enter. Use the host keyword. Okay, use the host keyword, and all other traffic must be explicitly denied. Okay, there is an implicit deny, but I will do it explicitly. So deny any. Exit. IP address on the appropriate interface or line. Line BTY 0 to 15. Access dash class. This name block BTY. Incoming traffic. Okay, exit. Okay. So PC2 will enter the BTY lines on R1net and no other host. Create access list 1 of 1 to block PC2 network from accessing FTP service on the FTP server. Use the host keyword, permit all other traffic. Okay. PC2's network from accessing FTP service of the FTP server. Okay. Okay. The source is not PC2. The source is all the network of PC2. All this network. Okay. This is the source. And the destination is only a host. The host is FTP server. This is the destination. Okay, the source is a network. The destination is a host. and the direction is this. Okay, this is the direction. And it's recommended to place ACL 1 is an extended access list. It's recommended to place an extended access list close to the source, so on fast Ethernet 01 interface incoming traffic. As you can see the arrow, okay, fast Ethernet 01 incoming traffic, because should be placed an extended access list should be placed close to the source. Fast Ethernet 01 incoming traffic. Okay. Okay, but first create the entry IP access no, access list 101, and the protocol FTP uses TCP protocol. Okay, with block. Okay, so deny TCP, and the source is this network 192.168.25.0, 192.168.25.0. You use the wildcard for the network 27. The wildcard for 27 is 31. Okay. And the destination is the FTP service on FTP server. And use the host keyword. So the destination is a host. And the IP address is this. Okay. And the port of FTP is equal to 21. Okay. Okay, deny TCP protocol from this source to this destination, port 21. Enter. And permit all other traffic. Obviously, you need to permit because there is an implicit deny. So you need to permit all other traffic. 1 permit IP from any to any. Okay, ready, and place on fast Ethernet 01 incoming traffic. Interface fast Ethernet 01. IP access group 101 incoming traffic. Okay, exit. Okay, very good. Ready. Configure dynamic NAT on R1 NAT. Create a standard named access list called Internet Access Control List to permit individual LAN traffic from routers R1 NAT and Boston. Okay. Create a standard named access list. Okay, this is the dynamic NAT on R1 NAT. Okay, on R1 NAT, a standard named access list called Internet Access Control List, ACL. Okay, IP access list standard. The name is Internet ACL, case sensitive. Internet ACL. Enter. Permit individual LAN traffic from routers R1 NAT and Boston. Okay, LAN traffic. So use the LAN interfaces the LAN networks on R1net and on Boston. Okay. All other traffic must be explicitly denied. When creating the access list, keep the following points in mind. Order your access list statements from smallest to the largest network. Okay. Don't include loopback networks in your access control list. Okay, individual LAN traffic from R1net and Boston. Okay, on R1net, this subnet 192.168.26.192. On R1net, this subnet 192.168.25.0. And on Boston, this network 172.16.35.0. So permit this network. First, from the smallest to the largest. This is the smallest, 172.16.35.0. 172.16.35.16.35.0. 172.16.35.0. Prefix 27. But use wildcard. The wildcard of 27 is 31. 27. The wildcard is 31. Okay, very nice. Enter. Now permit the second smallest is this 192.168.25.0. 192.168.25.0. But the wildcard is 27. 27 prefix wildcard. Okay, for prefix 27, this is a correct wildcard 31. Enter. And now this 192.168.26.192. 192.168.26.192. 26.192 and 26 prefix. The wildcard for 26 is 63. Okay, 26 prefix. The wildcard is 63. Okay, enter. And all other traffic must be explicitly denied. Here at the end, there is an implicit deny, but deny explicitly, deny any. Okay, exit. And create NAT pool, name it internet pool. Okay, IP NAT pool, the name internet pool, case sensitive, and use these addresses from 204 to 206. 204, 206. And the NAT mask is this 29. So it's 255, 255, 255, 248. This is 29 prefix, but in decimal 248. Okay, enter. Okay, configure dynamic NAT with overload using the access control list and NAT pool. Okay, IP NAT inside source list. This is the list. pool, use this pool. And overload to use PAT. Overload. Okay. Apply the NAT to the appropriate interfaces. Okay, obviously you will use NAT to reach internet. So gigabit 0 to 0 is outside. Interface gigabit 0 to 0 IP NAT outside. Okay, fast Ethernet 00, fast Ethernet 01, fast Ethernet 00 inside, fast Ethernet 01 inside, serial 000 also inside, serial 000 inside. Okay, very nice. And configure path on HQR1. Okay, here on HQR1, obviously to reach internet, configure path. Create a standard named access list called Internet Access List. Permit individual LAN traffic from routers R1net and Boston. All other traffic must be explicitly denied. Order your access control list statements from the smallest to the largest. Don't include loopback. Okay. Okay, do not include loopback. Okay, this access list is the same previously created on R1net. Is this? Okay. Okay, standard access list, internet ACL. This, okay. LAN traffic and R1net. LAN traffic on R1net. LAN traffic on Boston. LAN traffic on Boston. The smallest to the largest. The smallest to the largest. Okay, copy this, then apply. HQR1. Global configuration mode paste. Very good. Configure path using the interface connected to internet. The interface connected to internet is gigabit 0 to 0. IP NAT inside source list. This list. The interface gigabit 0 to 0. Okay. Okay, use PAT. Port address translation, so use overload. Okay. Apply the PAT to appropriate interfaces. Okay, obviously gigabit 0 to 0 is outside. Interface gigabit 0 to 0. IP NAT outside. Fast Ethernet 01 and 00 inside. Fast Ethernet 00 inside. Fast Ethernet 01 inside. Serial 000 inside. Interface serial 000 inside. Okay. Configure CDP and LLDP on R1 NAT and HQR1. Disable CDP on R1net and HQR1. Globally, as well on interfaces connected to Internet. Okay, disable on R1net, global configuration mode, no CDP run. Okay, and the interface connected to Internet is gigabit 0 to 0. Interface gigabit 0 to 0. CDP question mark enable. So use no CDP enable. Okay, exit. Okay, on interface gigabit globally no CDP run. Interface gigabit 0 to 0, no CDP enable. The same process on HQR1. Exit. Global configuration mode, no CDP run. Interface gigabit 0 to 0, no CDP enable. Exit. Enable LLDP global for both routers. Okay, on R1net, global configuration mode. Okay, LLDP question mark run. Okay, HQR1 LLDP run. Okay, disable LLDP on interfaces connected to Internet, but R1net and HQR1 routers. Okay, disable LLDP. Interface gigabit 0 to 0. No LLDP question mark. Receive and transmit. Receive. Also no transmit. Okay. Transmit. Okay, exit. On HQR1. Interface gigabit 0 to 0. No LLDP receive. No LLDP transmit. Exit. Okay, disable on the interface connected to Internet. Okay. Now configure NTP. Configure R1net and HQR1 as NTP clients to time synchronize it with NTP server 209.165.210. Okay, this IP is placed on Internet. Okay, R1net NTP server 209.165.210 NTP update dash calendar. Very nice. Okay. Also on HQR1, enter NTP update calendar. Okay, configure the server. R2 is client, configure the server. NTP update calendar. Now configure HQR1 as NTP server. And Boston to use HQR1 IP address as NTP server. Okay, the NTP server is placed on Internet. The clients are R1net and HQR1. Very nice. But now configure HQR1 as server and Boston as client. HQR1 NTP master. Enter. And Boston as a client. Go to Boston. NTP server. And use the IP address of 10.10.089 is this IP address. Fast Ethernet 00, this IP address. Okay. fast Ethernet 00, okay, and NTP update dash calendar. Very nice. Okay, check the network functional results. Show IP route on R1 NAT and show IP routes. Okay, very good. You will see the OSPF external to, okay, external to, okay, because the redistribution was configured. Very nice. Show IP route HUR1 and show IP route. Okay, you will see the OSPF, EIGRP, OSPF inter area, OSPF, EIGRP, OSPF inter area. Very nice. Show IP protocols on R1 NAT. Show IP protocols. Very good. OSPF. LAN interfaces specific. Very nice. Show IP route Boston. And show IP route Boston. You will see the EIGRP external, EIGRP external, EIGRP. Very nice. Demonstrate access control list from PC2 telnet R1 NAT. Go to PC2 telnet R1 NAT IP address fast Ethernet 01. Show running config. Fast Ethernet 01 is this IP. Connect password Cisco. Very nice. Exit. Now, okay, this should be successful, but from PC1 should fail. Okay, go to PC1. Telnet, use the IP address. Fail. Okay, very nice. PC2 should not be able to access FTP. Okay, PC2, command prompt, FTP, the IP address of the server, the FTP server. From PC2, access FTP server. Okay, trying to connect. Okay, error disconnecting. Okay, PC2 should not be able to access FTP. Okay, while ping is successful. Enter ping the server. Very good. Okay, very good. Demonstrate NAT. Okay, first ping the NTP server from any PC on area 88. Okay, for example, go to PC2, ping NTP server, The NTP server is this 209.165.210, 209.165.210. Okay, ping to server, success. Okay, from PC to ping to server, then to verify, show IP NAT translations on R1net. Okay, show IP NAT translations. Very nice. Inside global is the IP address of public IP address on R1net. Inside local, the IP address of PC2. Outside local, the NTP server. Outside global, NTP server. Okay, show IP NAT translations on HQR1 with ping NTP server from PCs on EIGRP. Okay, for example, from this PC0, ping the NTP server, ping 209.165.210, success. Go to HQR1 router, show IP NAT translations. Okay, inside global, the IP address, the public IP address on HQR1. Inside local, IP address of PC0. Outside local, NTP server. Outside global, NTP server. Demonstrate CDP and LLDP. Show CDP. Verify is disabled on routers. R1net. Show CDP. Sorry, show space CDP. Not enabled. Okay. Show LLDP. Show LLDP. Okay, is active. Okay. Okay, demonstrate NTP, show NTP status, show NTP associations on R1net and HQR1. Show NTP status. Okay, the NTP server synchronized to NTP server, very nice. Show NTP associations. Okay, the NTP server IP address. Also in Boston. Show NTP status. Okay, synchronized with this server HQR1. Very good. Show NTP associations. The IP address of the server, very nice. Thank you very much, my friends. Thank you.